Hello, today I'm going to do paper review assignment. The title is Modeling of Effect of Employee Injury Risks on Injury, Productivity and Production Quality Using System Dynamics by Mashal Farid and Patrick Neumann. The study is motivated by the importance of product quality for manufacturing companies. There is a growing recognition for human factors significantly contribute to companies' quality performance. While human factor intervention can lead to improved quality, neglecting human factor in the design of work system can result in poor work environment and degraded quality. Operator fatigue is a common issue linked to this quality deficit. So, human factors, if it is excluded from work system design, can lead to injuries for system operators. Work ill health carries significant costs, comparable to those of cancers combined, with musculoskeletal disorder, or we call it MSD, being the most reported lost time claim. MSD injuries result in direct costs such as sick leave, wages, and insurance costs, as well as substantial indirect operational costs that are difficult to measure, but can be many times higher than the direct costs. Employees with work-related injuries often perform below their optimal level, contributing to quality and productivity losses. So despite the evidence, HF is often given little consideration by managers and is frequently ignored during the design stage. Managers may not be aware of the importance of HF in achieving strategic goals and often view human factor solely as the safety issue. Consequently, HF-related issues are typically addressed reactively through problems and complaints, rather than proactively during the design phase. Retrofitting changes to address human factor issues can be expensive, difficult, and less effective. So, managerial brought to aware. There is a need for tools and models to help system designers and managers understand the impact of HF aspect on operational performance beyond health and safety. The current study explores the use of system dynamics modeling as a tool to support this understanding. The study explores the use of system dynamics modeling to examine the impacts of human factors on worker injuries, productivity, and production quality. The focus is on low back pain injuries, a common issue in manufacturing environment. The underlying logic is that human factor in system design affect LBP injury rates, which is in turn affect productivity and quality performance. The study uses SD, system dynamics modeling, which is distinct from other common modeling techniques like discrete event simulation and agent-based modeling. Unlike other modeling techniques like DS and ABM, SD is particularly suited for understanding cause-effect feedback relationship within a system. SD models are based on mental models of managers, providing a platform to test assumptions about the system and understand interaction between factors such as low back pain injury risk and performance. On model testing, the model was run with two sets of inputs. The first set was the base case values, which represent the standard condition under which the model operates. The second set involved a sensitivity analysis. This approach was used to examine how changes in individual parameters affect the model's behavior. Simulation period was simulated over 5 years period. The duration was chosen to ensure that the model could reach a steady state or exhibit a trend, providing a comprehensive view of its long-term behavior. And then they make a phase validation to ensure model validity. It was performed with two assembly plan managers. The step involved reviewing the model's logic and output to confirm that they align with real-world expectations and experiences. These testing methods were designed to evaluate the model's robustness and reliability in simulating the effect of employee injury risk on productivity and production quality. The result for the four main model parameters are shown: fraction reporting pain, human error probability, production rate, and rework rate. On fraction reporting pain, model showed that the percentage of operators reporting low back pain increased from approximately 0 to 1.3 over the 5-year simulation period. This is lower than prevalence reported in the literature, which ranges from 7 to 15%. On human error probability, the model indicates a 40% increase in human error probability over the simulation period. Production rate, there was a slight drop in the production rate by 0.2% over the 5 years period. On sensitivity analysis, we can see peak hand load, shift length, and spinal load while working. Result. So on the peak hand load and spinal load while working, we can see inverse relationship between presenteeism, working while in pain or injured, and yield rate. The results show an inverse relationship between while working in pain or injured and yield rate. And then on shift length impact, HEP increased by 0.04% slightly for every additional hour worked, and emphasizing the importance of managing work hours to maintain quality. Discussion point on implication. The paper suggested integrated approach to human factors and collaboration between disciplines, and also finding to improve system dynamics modeling and strategic design decision on human factors. And there are educational implications. The paper points out the lack of human factor aspect in some engineering education programs. Conclusion. The study demonstrates a novel application of ST modeling as a tool to help industry professionals understand the impact of human factors, risk factors on both the health of operators and the performance of manufacturing system. And quantification of risk factors. The model successfully quantifies the effect of low back pain risk factor on operator health, as well as on quality and productivity within a production system. These effects are shown to potentially intensify over time. And then simulation result. Over 5-year simulation period, the percentage of operators reporting pain increased from approximately 0 to 1.3%. Human error probability increased by 40%, and the production rate dropped by slight only to 0.2%. Long-term impact on design decision. The study highlights a cautionary point for managers and designers, noting that poor design may not leave immediate impact but can lead to quality problem over time. The sensitivity analysis revealed an inverse relationship between presentation and yield rate. And shift length is identified as a critical factor. Among the risk factor analyzed, shift length was identified as having the greatest effect on quality, with HEP increased by 0.04% for every additional hours work. Model feasibility and future work we'll discuss in the next slide. The limitation of the model only address a limited number of known injury of risk factor, and suggesting the actual impact on quality and productivity could be higher than indicated. Current model demonstrate the feasibility and modeling technique, though further development and detailed validation are needed. Further studies with different scenarios to include additional risk factor and injury categories may be feasible. Exploration of the broader impacts of human factor on quality and productivity. Finally, the presentation is concluded. Thank you for listening, and have a good day.